Hello, Mr. Malden, and this is the Math Toolbox, where I teach you how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. This video today is about factoring linear expressions, which is really kind of like two lessons combined into one. So it's going to be a little bit longer of a video. So you're welcome to fast forward in the video to the part that you'd like to see. But ultimately, we're trying to factor linear expressions. So we're just going to hop right into this. In order to factor linear expressions, you're going to have to be able to find the greatest common factor between two numbers. So we're going to start with something really easy, and then we're going to build up from there. So I want you to tell me, what are the factors of 8? All right? And the way that you do that is you pause this video, you go back and you try to work on it yourself, then you unpause it to see what the answers are. So any of these videos, you should be watching them with a sheet of paper or a whiteboard or something like that, and a pencil or a dry erase marker to work out the problems yourself, because I tell you to pause quite a bit to be able to try it yourself, and then you can come back. So that's the best way to be able to do these videos, so that you have a little bit of interaction and you try it. All right. If you haven't paused already, do that. Find the factors of 8. The factors of 8, all right, are going to be all the numbers that you multiply together to get to 8. So you'll see right here, 1 times 8 is 8, and 2 times 4 is 8. So there's 4 different numbers that you can multiply together to get 8. So all 4 of those numbers are factors, all right? Now, a lot of times your teachers have you write it like this, all right? The factors of 8 are 1, 2, 4, and 8. All right, that's not a bad way to do it. That's a really good way to do it. It's a great way to represent it if you're like writing it on a document or in an answer for, a fill in the blank or something like that. If the question just asks what are the factors of 8, that's a great way to write it. For the nature of this lesson today, I want y'all to write it like this, where you put the number on top, and then underneath it, I want you to write the factors in order from least to greatest, just like this. And it'll make sense as we go along the video why I want you to write it like this, all right? So in order to be able to work with these factors, I want you to write it like this. So take the number right there that you're needing to factor, put an underline underneath it, and then write the factors down below, all right? So try that one with this next one. Tell me what the factors of 18 are. Again, pause the video. And then you can get your factors, and then you can come back and be able to get what the right answers are in just a second. All right, so if you have already paused the video, then you've got your answers. The factors of 18 are going to be all the numbers you multiply together to get to 18. So you've got 1 times 18, 2 times 9, 3 times 6, and the like, all right? Those are the factors, all right? If you're looking for a quick way to do this, if you're having trouble finding factors, that's not really the nature of today's lesson, is how to find the greatest common factor. I'm just assuming that you already know how to do that. But if you're struggling with that, all right, here's how I do it pretty quickly, all right? I'm going to start with the easy ones, all right, the easy numbers. 1 times 18 is 18. So I'm going to start with the lowest and then start with the number itself. Those are going to be factors. Then I'm going to go to 2, all right? I'm going to ask myself, will 2 go into 18? And if it's an even number, all right, like 18 is, even numbers end in 2, 4, 6, or 8, or 0, all right, then 2 will go into it, all right? So then I'm going to divide 18 divided by 2, that's 9, okay? Then I'm going to ask myself, will 3 go into it, all right? So I'm going to put a 3 down, and well, I could put my 3 over here because I'm not for sure that it'll go into it yet, all right? Here's an easy, quick way to know if 3 will go into a number. If you'll take the numbers that you're asking yourself, will 3 go into that number? And you'll just add up the numbers that you see. So for 18, I'm going to add up 8 plus 1. That's 9, all right? If 3 will go into 9, then 3 will go into 18 as well. That's a really quick, easy way to know about 3s, all right? So 3 will go into 18 because 8 plus 1 is 9, and 3 will go into 9, so 3 will go into 18, and 18 divided by 3 is 6, all right? And I didn't leave myself much space right here, but there's 2 other numbers in between 3 and 6 that I need to try. I need to try 4 and 5, all right? So I'm basically starting at the greatest and least, then working my way down until I get to the middle. Now I just need to try 4 and 5. Will 4 go into 18? No, 4 will go into 16 and it'll go into 20, but it won't go into 18. And 5 will only go into numbers that end in a 0 or a 5, all right? That does not end in a 0 or 5, so 5 does not go into it. So those are going to be the factors of 18. And that's just kind of a quicker way to be able to find the factors of a number, all right? Okay, let's go ahead and move on. And we're going to, on this one, on your piece of paper, I want you to write both numbers down separately, kind of on different sides of the paper, and I want you to factor both of them, all right? And then once you factor both of them, I want you to circle the number that you see in both lists, all right, that is the greatest number that you see in both lists, all right? Go ahead and try that, all right? Pause the video, try that, and then unpause it to see what the answers are. Okay, so the factors of 28 are 1, 2, 4, 7, 14, and 28, and there's the math that proves that right there. And then the factors of 16 are 1, 2, 4, 8, and 16, and there's the math that proves that. And then now I'm looking in both lists, all right, for a number, the greatest number that we have in common. So in both lists, you have a 1, you have a 2, you have a 4. Those are all common factors, all right? But then it stops after that. There's not a 7 in this list, and there's not an 8 in this list, so on and so forth, all right? So the greatest of the common factors is 4. That is the greatest common factor, all right? And finding the greatest common factor is the first step in factoring linear expressions. So I taught this lesson yesterday to my students, all right, where we just had the first half of this lesson was just finding the greatest common factor, because that's going to be the first step in factoring linear expressions. So let's continue on with that step and some more examples, all right? Let's now take this into 7th grade. So far, this is kind of a 5th grade concept, finding the greatest common factor, all right? We're going to bring it into 7th grade by including a number with a variable, all right? And it's not nearly as hard as it might seem at first. This is how I want you to do it, all right? So I'm going to teach you how to do this one, and then the next one I'm going to kind of give you a chance to try that one, okay? All right, so whenever you are factoring a number that has a variable, what I want you to do is split them off, all right, where you've got the number, all right, so you have like these branches of a tree, all right. The tool that I'm kind of using is a modified form of the factor tree, all right, where I've got branches here, all right, so I've got the 9 and I've got the y. I've just split them off. Then what you're going to do is find all the factors of the number, all right? You see how right here I've got the factors of 9 are 1, 3, and 9, all right? So you're going to find the factors of the number first, and then you'll include those numbers with the variable as well. So underneath the y, I've got 1y, all right? And you don't see the 1 right there because it's an invisible coefficient. All right, so there's no 1 right there because when the coefficient is 1, we make it disappear. All right, then I included 3 with y, so that's 3y, and then 9 with y, that's 9y. So all these 6 numbers right here are all factors of 9y, and this is the math that shows you how. All right, 1 times 9y is 9y, 3 times 3y is 9y, so on and so forth, okay? So those 6 numbers are the factors of 9y. The easy way to do that, again, is to split it off, the 9 and the y, find the factors of the number, then include those numbers with the variable itself. And all of those numbers, the numbers without the variables, the numbers with the variables, those are all factors of your coefficient with your variable up there. All right, so now then, I don't have this one on the screen, but I want you to try this one. I want you to factor 8x. All right, so go ahead and pause this video, try to factor it yourself with the method I just told you about, and then come back to see if you got the right answer. All right, so I'm going to split off 8 from x, just like that. Then I'm going to write the factors of 8, which are 1, 2, 4, and 8. And then I'm going to include those numbers with the variable. 1x is just x, 2x's, 4x's, and 8x's. All right? So the factors of 8x are 1, 2, 4, 8, x, 2x, 4x, and 8x. Those are all the factors of 8x. All right. So let's try this one. You've got two numbers now. We want to know what the greatest common factor is of two numbers who both have variables. So now what you need to do is you need to factor both of these numbers. Split off the 12 from the t, split off the 30 from the t, all right? And then I want you to take a guess. You haven't learned how to do this yet, all right? Maybe you already know how to do this, but take a guess on which one you think is the greatest common factor. Circle it, and then come back to see if you got the right answer or not, right? Okay, so you should have paused it already. You should have tried it. If you haven't, do that, because I'm about to tell you the answers. All right, the factors of 12, t and 30t are shown up right here. All right, these are all the numbers, and there's all the math that proves it, okay? Just like that. So we have the factors of 12, all this right here. Then we included that with the t over here, and the same thing with the 30 and the 30t. All right, just like that. So these are all the factors of 12t and 30t. Now then, we want to find the one that is greatest that appears in both lists, all right? And we're probably tempted to say the 6, all right? Because the 6 is the greatest number, all right? But if both of your factors, or both of your numbers, all right, have a variable, then you want to include that variable with the greatest common factor. If they don't both have the variable, then obviously that won't be in both lists. You'll just include the greatest common number, all right? Greatest common factor is the number. But if they both include the variable, if you see it with the variable on both sides, that's the greatest common factor. So in this case right here, 6t would be the greatest common factor, right? And the same goes for, that same kind of method also kind of goes for factoring with negatives, all right? Not the same as the last, that last slide. The way that we factor numbers with variables and negative numbers, I split them off just like I do with splitting off the number with the variable, right? The coefficient with the variable, right? I don't think I said that very clearly, but you'll see here in just a second what I mean by that. All right, so go ahead and try this now, because you see that I kind of split this off, and then come back and see if you got an answer. All right, get the right answer. All right, the factors of 21y. We split 21 off of y, all right, and we get 1, 3, 7, and 21 for the factors of 21, and we're going to include those with the y's over here, just like that. All right, and then with the negative 35, we split off the 35 from the negative, right? So first we're just finding the factors of 35, which are 1, 5, 7, and 35, I'm sorry. And then we're going to include those factors with their negative signs as well. So negative 1, negative 5, negative 7, and negative 35. Those are all factors of negative 35. And the reason why is because 1 times negative 35 is negative 35. And 5 times negative 7 is negative 35, and so on and so forth, all right? So those are all factors. So if you're factoring a negative number, split off the number from the negative, just like you would if there was a variable, just like that. Find the factors of the number, then include their opposites as well, all right? The greatest common factor between these two numbers would be 7, because 7 appears in both lists, all right? There's a number with the variable right there, but you don't see the 7y over here, all right? So the greatest common factor is going to be the 7, all right? Okay, now then we're going to move on into, we've talked about greatest common factor. We're just going to take the next step and we're going to move on into factoring linear expressions. But there is a little bit of a conversation that needs to be happening before that. The factoring linear expressions is really just reverse distributive property or backwards distributive property, all right? So if you've got a number on the outside of a grouping like this, indicating that that number is being multiplied by the grouping, all right, then you need to distribute that multiplication to everything on the inside of the grouping, all right? If you haven't learned how to do that yet, then you can go back to watching the video using the distributive property to expand linear expressions. That video is already posted. You can go back and watch that, and it's going to teach you how to do the distributive property, all right? But today we're doing the backwards one. So we need to first understand distributive property, that we're multiplying that number times everything in the grouping. This is the expanded form. So 2 times x plus 3 is the same thing. It's equal to 2 times x plus 2 times 3, all right? Which simplifies to 2x plus 6, okay? So when you're simplifying this expression right here, you come up with 2x plus 6. Now, factoring linear expressions is going backwards. Essentially, we're taking this 2x plus 6 and we're going backwards to write it as an expression that includes multiplication, right? Includes the greatest common factor inside the expression, all that. It just looks like we need to apply distributive property to it. So we're going backwards, all right? And this is how we do that, okay? I'm going to take that one that we have right here, our answer, 2x plus 6. First step you're going to do in order to go backwards to represent it as what we would see for distributive property, all right, is we're going to find the greatest common factor for each of these numbers. So we have 2x and we have 6. So we're going to take this one and we're going to factor them. I'm going to split the 2 off from the x just like that, right? What are the factors of 2? 1 and 2. Then we're going to include that with the variables, all right? Those are the factors of 2x. And then of 6, you have 1, 2, 3, and 6. Those are the factors of 6. So the number that is the greatest that appears in both lists is 2, right? So our greatest common factor is 2. Right? Then you're going to take that greatest common factor and you're going to put it on the outside of a parentheses with the plus sign inside and 2 spaces on either side of the plus sign, just like that. So we took that greatest common factor and we put it right there on the outside of a parentheses, just like that. That was step 2. All right? Step 1 is to find the greatest common factor. Step 2 is to put it on the outside of a parentheses, but on the inside you have 2 spaces separated by a plus sign, okay? And then you're going to divide each of the factors, all right, or each of the add-ins, sorry, the original add-ins, and we're going to put their quotients right here in the missing spaces, all right? So we're going to take 2x and divide it by 2, right? Which whenever you're dividing a variable with a coefficient by a divisor, all right, you're just dividing the numbers that you see. So 2 divided by 2, that's 1, all right? And then you're keeping the variable, that's 1x, all right? So 2x divided by 2 is 1x, which we can simplify to just x, okay? So we're going to take that x right there, and we're going to place it right inside the parentheses down here in the empty space. That's the first one. Then we're going to take the 6, all right, divide it by 2. And we're going to put that number in the other space. 6 divided by 2 is 3. There's our empty spaces filled in. All right? And our expression right there, when we did backwards distributive property, also known as factoring linear expressions, when we factor that linear expression, we got 2 times x plus 3, which makes sense because, you know, that was our original problem. All right? Let's try another one, though. Okay? We're going to try 4x plus 16. All right? You can either pause this video and try that one, seeing what you come up with, which is what I recommend that you do, or you can listen to me as I walk through the steps again. Okay? So go ahead and pause this and try it if you haven't already. Okay. All right, so we've got 4x plus 16. We're trying to find the greatest common factor of we're trying to factor this linear expression. And the first step is to find the greatest common factor of the two numbers. So we've got 4x and 16. We're going to find their factors. For 4x, we split off the 4 from the x. We find the factors of 4, which are 1, 2, and 4. Then we include that with the x's, x, 2x, and 4x. Right? And then the factors of 16 are 1, 2, 4, 8, and 16. And the greatest number that appears in both lists is 4. All right? So we're going to take that 4 and we're going to put it on the outside of parentheses, leaving blank spaces for the add-ins on the inside and a plus sign. Then we're going to take each of the original add-ins, so 4x and 16, and we're going to divide it by the greatest common factor, 4, to get what our answer is going to be. So 4x divided by 4 is just 1x, because 4 divided by 4 is 1, and we keep our x. And 1x can be simplified to just x. And then 16 divided by 4 is 4, right? So you have quotients of x and 4, then you're going to place those x's in that x and that 4 inside the parentheses and the blank spaces on either side of the plus sign, just like that, and you have factored your linear expression. So 4x plus 16 factors to 4 times x plus 4. All right? Go ahead and try this one. Pause the video, try it, and then come back to get the understanding. All right? Okay, so I see 9h plus 15. I'm going to factor each of the numbers first because that's my first step. All right? 9h, I'm going to split off the 9 from the h, just like that. I've got 1, 3, and 9. 1h, 3h. I started to write x's because a lot of times with math we use variables, we use x. It's kind of the default. All right? So then I'm going to include the h with that 9 right there. That's 9h. So those are all the factors of 9h down there. And then of 15, you have 1, 3, 5, and 15. Those are the factors. And the greatest common factor is going to be 3. Right? So we found that part. I'm going to write this over here. 9h plus 15, and we're going to say equals. All right, so we're going to take that 3, we're going to put it on the outside of parentheses, just like that, put a plus sign, and we've got 2 blank spaces for 2 quotients to go, or 2 other add-ins to go. The quotients of these numbers are going to become add-ins. All right, now to find that number, all right, the first one, we're going to take the first original add-in, which is 9h, and divide it by 3. And whenever you're dividing a number, a variable with a coefficient, by a divisor, you're just going to divide the numbers and then keep the variable. So 9 divided by 3 is 3. We're going to keep our variable h. All right? Then we're going to go to 15. We're going to divide it by 3, and we're going to get 5, just like that. All right? So our final answer is 3 times 3h plus 5. That's, we factored the linear expression to be 3 times 3h plus 5. All right? Now then, we're going to try this one. This next one. And I'm going to give you a little warning before we start it, all right? Whenever you see subtraction in a problem like this and you're working with it, it's best to turn that to an addition problem by applying keep change opposite. So try that, all right? Apply keep change opposite to this one, which means you're going to have a negative number there, that negative 18, to be able to factor. So try to remember what we just talked about, that you can split off the number from the negative, just like you would if it were a variable. So try to go ahead and factor this linear expression and then come back to see if you got the right answer. All right, we have 12n minus 18. All right, first thing I'm going to do is apply keep change opposite to turn that to an addition problem. So I'm going to keep the number in front, change the subtraction to addition, and the next number I'm going to make it its opposite, just like that. So 12n minus 18 is the same thing as 12n plus negative 18. Now that I'm going to factor 12n, all right, and I'm going to factor negative 18. I'm going to split off the 12 from the n, all right? I've got 1, 2, 3, 4, 6, and 12. Those are all factors of 12. So I've got n, 2n, 3n, 4n, 6n, and 12n. And then for negative 18, again, I'm going to split off the 18 from the negative, just like that. I've got 1, 2, 3, 6, 9, and 18. Those are the factors of 18. And I'm going to include the negatives with it. Negative 1, negative 2, negative 3, negative 6, negative 9, and negative 18. Those are all the factors, right? So the greatest common factor that I see in both lists is a 6, right? I see a 6 in both lists. This one has a 6n, but that side doesn't, okay? This one has a negative 6 over there, but that doesn't over there, okay? So we see a 6 in both lists. We're going to take the 6, okay? We're going to put that as our number on the outside of the parentheses. Put a plus sign on the inside, just like that. Then we're going to divide our original add-ins by the greatest common factor. 12n divided by 6 is 2n, all right? And negative 18 divided by 6 is negative 3. So we've got 6 times 2n plus negative 3. Now then, at the very end, just like I applied keep change opposite to turn that into an addition problem, I want to clean it up if I see any plus negatives or minus negatives. So I'm going to clean this up by applying reverse keep change opposite. So I'll have 2n, change that to minus, and the opposite of negative 3 is 3. Put that on the inside, and you've still got your 6 on the outside of the parentheses. So your final answer is 6 times 2n minus 3, right? And that might be a roundabout way to doing this. You don't have to change that to a plus negative, all right? But when you get to this next problem, you're going to see why I always tell my students to change that to add the opposite, all right? Here's the next problem. Let's try it, all right? So again, try this one, all right, at home. Pause it. There is going to be something a little bit different from this, so that I'm going to talk about here in just a second, but just give it a shot. See if you can come up with the correct answer. All right, write this on my board, and then we'll roll with it. Negative 8x minus 6. We're going to factor this linear expression. I'm going to put an equal sign because I know I'm going to write my answer right here. Just a second. Right? First thing I'm going to do is negative 8x. And then I'm going to do keep change opposite, so I'm going to be factoring negative 6. All right? Let's start with negative 6. All right? I'm going to come back to this one here in just a second because that's going to be pretty complicated. All right? All right. I'm going to break this off with the 6 and the negative, just like that. Hopefully you remembered how to do that. All right, find the factors of 6, 1, 2, 3, and 6. And then include that with the negatives. Negative 1, negative 2, negative 3, negative 6, just like that. All right, now then over here I'm going to factor negative 8x. All right, this is where it's going to get a little complicated. Not too bad, but just a little complicated. All right, you're going to split off the number. Then we're going to have a negative form of it. All right. Then we're going to split off our x and then the negative form of it. All right, just like that. So we have like a huge list of numbers here that we're going to be using as factors. So factors of 8 are 1, 2, 4, and 8. Then we're going to include all the negatives with it. Negative 1, negative 2, negative 4, and negative 8. All right. Then we're going to include all the x's. All right. So we have 1x, 2x, 4x, and 8x. And then we're going to include all the negative forms of that. Negative x, negative 2x, negative 4x, and negative 8x. And the reason why is all these numbers are numbers that you can use to multiply to get the negative 8x. Okay? That's how we do it. Negative 8x times 1 is negative 8x. Negative 4x times 2 is negative 8x. Negative 2x times 4. Negative 8x times 8. Negative 8 times x. Negative 4 times 2x. Negative 2 times 4x. Negative 1 times 8x. All right? So they kind of pair like this, if you will. Those pair together, and then I don't want to make my board too messy, but the other ones pair together. So anyways, now we're going to look in both lists to find out what the greatest common factor is, all right? And like I said a while ago, all right, if both numbers had the variable, we would include the number with the variable. This is very similar, all right? We're going to include the number if there's a negative. They both have a negative form, that's going to trump, all right? So we're going to include the negative form of the number, all right? Which is not the greatest common factor, it's a common factor. We're going to include the negative inside of it, which makes it least in this sense because it's negative. But we want to include the negative because it'll make our expression look a little bit more simple, all right? And it's possible that some of your representations will be a little bit different. I'm going to try to show you all of these things, okay? But we're gonna find the number that's on both sides. It's the greatest number, and if there's a negative with it, it's going to trump, okay? So we've got the number on both sides that's the greatest is 2, all right? Because there's no 3's over here, and there's no 4's, there's no 6's over here, there's no 8's over there. So 2 is the greatest number, and they both have a negative 2. Now this one had a negative 2x, which would be a trump, all right? They both had those. We would include that, right? But we have a negative 2. So we're going to write that as our common factor, just like that, all right? And then we're going to divide our our add-ins, our original add-ins, by that negative 2, all right? We're going to have a plus sign right here. You have negative 8 divided by negative 2 is going to be a positive 4, all right? And then you've got negative 6 divided by negative 2 is going to be a positive 3. That 4 had an x on it, so just like that. That's one way that you could see this, all right? One representation, all right, that you can see. Another representation, and probably some of your teachers are going to advocate for the greatest common factor. And as I'm sitting here thinking about this, that's probably a simpler way to be able to explain this anyway. So your teachers, if they advocate for that, they have good grounds for that, all right? You've got a 2 on the outside, you're going to have a negative 4x here, and then you're going to have a minus 3 as a final representation as well. So this also would be another way to represent that. Now, there's going to be an argument about which is a simpler way to do this, all right? I like this way up here, personally, all right? A lot of your teachers are going to like this right here, all right? So I'm going to let them do the arguing for you. But I like this one right here. So including the number with the negative, all right? Neither one is more simple than the other, all right? Because they all have the same amount of characters. We just have the negative here instead, and we have that plus sign turned to a subtraction, right? So there's still the same amount of characters in each list. But anyways, we got to move on. All right, we've got a fraction. What are we going to do with the fraction, all right? Last example, we have this fraction 4 over 15x, so 4/15 x plus 12/25, right? Okay, what you're going to have to do if you have fractions is you need to find the greatest common factor of the numerators. That's going to be your new numerators, your greatest common factor right here. All right, when you put your number on the outside of the parentheses, all right, the number on top is going to be the greatest common factor of your numerators. The number on bottom is going to be the greatest common factor of your denominators. So if you have fractions as add-ins and you're factoring them, then you need to find the greatest common factor. Your greatest common factor is going to be a fraction, all right, which means you need to find a new numerator and a new denominator. Right? And then the way that you do that is you look for the greatest common factor of 4 and 12, right? If you did that, you could write your lists out here, all right? But the greatest common factor is going to be 4, all right? So we're going to put 4 right there. And then we're going to find the greatest common factor of 15 and 25. And the greatest common factor of those two numbers is 5, right? So now then we need to divide our original add-ins by the greatest common factor. And we want to do that not by using keep, change, flip, what we're usually divide by fractions. We're going to take, because we know these will go in there completely because we found the factors, the greatest common factors of our numerator and the greatest common factor of our denominators. We know we're going to have a clean division problem right here that's not going to give us decimals, so we don't need to apply keep, change, flip. All right? We're just going to take, in our add-ins, that fraction right there, divide the numerator by the numerator of your greatest common factor. So 4 divided by 4 is 1. And then divide your denominator from this add-in from your denominator of your greatest common factor, which is 15 divided by 5. That's 3. Just like that. It's going to include your x. And then we're going to do the same thing over here. 12 divided by 4 is 3. 25 divided by 5 is 5. Right? So if we took this and we factored that linear expression, we're going to come up with 4/5 times 1/3 x plus 3/5, all right? Where 4/5 is the greatest common factor of these two fractions, right? And again, super easy to find once you kind of know what you're doing. You find the greatest common factor of your numerators, that's 4. The greatest common factor of your denominators, that's 5. And then you divide each number by their respective number that you need to divide it by. So for this add-in, the numerator divided by the greatest common factor's numerator, 4 divided by 4, that's your 1. 15 divided by 5, that's your 3. 12 divided by 4, that's your 3. 25 divided by 5, that's your 5 right there. All right? All right. This was a long video, probably one of the longer ones we'll have all year because we kind of embed a lot of information in this video. If you have any questions, write them down below in the comments. I hope you have a great day. We'll see you next time.